In today's video, I'm going to be tearing down and attempting to repair this Pioneer DDJ-1000 DJ Controller. And I'm hoping it'll be quite an interesting video. A couple of years ago I did a teardown of my DDJ-400 and it was quite interesting and the video did very well, but that's a much more basic controller. This on the other hand is Pioneer DJ's highest end controller. So while obviously it's got a lot more functionality, it's got bigger jog wheels which are they're pressure sensitive on the top, they've got LCD screens in them, so that hardware will be interesting to take a look at in itself. However, this DJ controller also has things like a built-in mixer. Most DJ controllers, the mixer section is just additional controls that go off to the computer does all the mixing and outputs the audio again. Whereas this has a full-on digital mixer inside it, and it's got inputs on the back, 4 different inputs, so you can actually send different devices into this and mix external devices with the internal playback. So it's actually really quite powerful. Looking at the specs on paper, this seems to roughly compare to something like the DJM-750 Mark II, which is already quite an expensive mixer. So it'll also be interesting to take it apart and see how all the mixer stuff works, see what hardware they use. But as I mentioned, this has a couple of faults. And I bought it faulty with the intention of seeing, doing a teardown and seeing how fixable it is. So it's got 3 main faults. The seller listed it, or said that it had a small liquid spill, which isn't a good sign. But in the process of listing it and explaining the fault, they kind of diagnosed where the problem lies, or at least one of the problems. So that kind of made me confident enough buying this, knowing that I can at least fix the main fault that we'll talk about. So the 3 faults it has. The first one is probably the most significant one in terms of using it, and that is these buttons up here don't currently work. These are all on a separate circuit board. There's one board here and there's another board here that connects into this board, and then this goes off the main board. And when this board's connected to the main board, it doesn't power up, and it flashes the quantized LED, which the service manual states is a voltage error, so the voltages have gone out of spec. But when that board's disconnected, it starts up fine. And that was the amount of testing that the seller had done. They said when this board's disconnected, it otherwise works fine. And that's what made me confident in trying to repair this. Because having taken these sorts of things apart before, I know that they don't actually really have digital communication between all the boards. All of these boards, with all the buttons and inputs and LEDs and jog wheels and potentiometers and stuff, all they do is they're just basic passive components. They're literally the buttons, the LEDs, and the potentiometers and stuff like that. Maybe a couple of resistors, capacitors, transistors, basic passive components, and then massive ribbon cables that connect all of those up to the main logic board. So on this board up here that's faulty, there'll be like a 20-way ribbon cable, and that'll carry a different wire for each button and a different wire for each LED. And then these boards are actually very simple. So assuming the voltage error is caused by some sort of short circuit or failed component on these boards, presumably due to the liquid spill, it shouldn't be too hard to repair or rebuild those boards. Worst case if it comes to it, the replacement board for this only costs about £50. They're just not very easy to get. There's a lot of stock issues at the moment. But worst case, that could be done. So yeah, we'll need to take this board out and fix that there. But one thing that's quite good is you'll notice this is an asymmetric controller, which means that each deck is identical, it's not mirror image. And that means that this board over here, that serves these loop buttons, is identical to the board here, that serves the loop buttons that doesn't work. So that means I've got one known working board, so I can take that out and test it and compare the values I can read from it with a multimeter to the faulty board and hopefully find where the fault is. As for the other faults, the first one is that the crossfader doesn't work. They mentioned this in the listing, and they sort of mentioned it saying, oh, the crossfader maybe runs via the boards that disconnected. I knew that wasn't the case because I checked the service manual. But I saw that they had the crossfader sign set to through on them all, and I thought, oh, maybe they just didn't know that they had to set that to the channel. But I've tested it, and no, the crossfader doesn't work. The other problem that sounds very catastrophic, but you can work around it, is that for some reason none of the audio outputs seem to work. So the headphone output nor any of the audio outputs on the back seem to actually output any audio, which is quite concerning. Now, in terms of using it, you can very much get away with that, because what you can do is you can get an external audio interface, connect it to a laptop, and set up rekordbox to output through that instead of the controller. And as long as you've got one that's, say, 4 channels, you can have 2 channels assigned for this output to speakers and 2 channels assigned for your headphones. And you can set that up in rekordbox and that works fine. And I've tested that and it's okay. So you don't really need the audio outputs on this. And I suspect that'll be quite hard to fix, but we'll see if we can poke around and see if we can find anything obvious causing the problem. And there's a little bit sort of residue of some sort inside this jog wheel here. You can probably just see there. That's on the LCD inside it, so I'll need to take that apart to clean it. But for a teardown video, it'll be quite interesting because now I've got an excuse to take apart the jog wheel and see how this works. Because this might be a bit different to the DDJ-400 because it should be a lot more precise. But yeah, other than that it works. So we can turn it on. It's very bright, so you probably won't be able to really see it, but it starts up absolutely fine, everything lights up. The only other thing I've really noticed is that the Q LEDs all flash. That indicates that the crossfader needs calibrated, and the problem is because the crossfader isn't working, I can't calibrate it. So you can go into the service menu on it, set up the crossfader calibration, where basically you need to put it in a bunch of different positions and press a button. But because it can read the values that are from the crossfader, it realises that they're not changing, and it won't actually let you save the settings. So these all flash, which is a little bit annoying, but they still do work as Q buttons. So when you're actually using it, the Q does work, the LEDs are permanently blinking. But yeah, what we'll very quickly do is we'll do a very quick tour of the device just to show it for people who haven't seen this sort of thing before. Then we'll take it apart and we'll see what it's like inside, see what condition it's in, and hopefully get this board out and try and start debugging it. Okay, so just a quick tour of it. So this is the outside of the DDJ-1000. You've got these two big jog wheels, which are very similar to the ones you'd find on a CDJ. In fact, they're full size and they've got a mechanical top, so you actually push down, they're not just capacitive. And these are even adjustable, so there's actually tension adjust, so it's definitely very high end. You've got the loop, but the manual loop buttons up here, which are the ones that aren't working on this side. The track browse button, slip mode, quantize buttons, they also don't work on this side, but you can kind of do that in the software, so it's not as big a deal. You've got various performance pads, loads of different modes, cue buttons, play buttons, full-size pitch fader. It's a very nice controller, and it's kind of the same, the closest you can get in a controller to a sort of club standard layout with like a pair of CDJs and a Pioneer mixer. Here you've got the mixer section. This is the bit I'm most interested in sort of looking at. Is you've got obviously 4 different channels. These decks can each do 2 layers, so you can switch between 2 layers and kind of have essentially 4 decks. But if you look up the top here, you can switch them. So you can switch them between USB-A or USB-B because there's 2 USB ports, so you can have 2 laptops connected at the same time if you're wanting to like DJ with someone else or hand over between 2 people. But you can also switch these to phono/line. So you could, for example, have the 2 center channels on USB using the controller and have the 2 outer channels on a line input and have a pair of CDJs, XDJs, turntables, something off the side and do proper 4-deck mixing. And for those, there's just inputs on the back. So there's just a bunch of RCA inputs on the back. And they do seem to work. So it's only the outputs that don't work. The inputs do work. So the A to D stuff seems to be fine. It's just the DAC that seems to potentially have issues or something related to that. Other than that, you've also got power input, microphone input. There's 2 USB ports there. And then for the outputs, you've got a pair of TRS jacks for the booth output, RCA and XLR master outputs. And obviously, they're the ones that aren't working currently. But yeah, that's sort of looking at it there. Seems like a very nice controller, really nice hardware. And I suppose the thing I haven't mentioned with this is in terms of the cost. To buy one of these new is about £1,200. It's not a cheap bit of kit. And even to buy them used at the moment is about £1,200 or more because Pioneer's got no stock. So loads of people are selling this for huge prices. So yeah, if we can fix this, it would be definitely quite cool. Definitely a good deal being able to fix this. So yeah, so what we'll do is we'll flip it over, take a look inside, and see if we can get down to this board here and see if we can find out what's wrong with it. Cool, so we went upside down and we can now take the bottom off. Now, you'll notice that all the screws are already removed. This was how it was shipped to me, which is a bit concerning, but they have included all the screws in the box, so that was all fine. So I can put it back together. I suspect they've just done it because obviously, with it being able to start up, they've obviously left that loop board disconnected. And yeah, as you can see here, this cable is hanging off. So I suspect this cable is the one that will go up to that loop board that's presumably got some sort of liquid damage. And if I connect this, it won't then start up. Apart from that, condition looks okay. There's some slight residue of liquid damage around here. So I suspect there's definitely liquid damage. But the jog wheels all still seem fine. They all seem to work fine. And apart from that issue with the DAC, this main board seems to be okay. And the crossfader, this main board seems to be okay. So hopefully there's nothing too catastrophic liquid damage wise, but we'll just have to see. So what I'm going to do is I'm just going to double check that the fault is definitely still present, because what you always want to do is you don't want to like spend ages trying to fix something and then find it's actually not got the fault. So I'm going to put this board, but this cable back in, and if the listing is correct, what will happen is when I turn it on, it will now not start up and the quantize LED will start to flash. So yeah, let's flip it over, try powering it up. It probably shouldn't work, and then we'll start taking it apart. Okay, so now if you try and turn it on with that cable connected, see what happens. Yep, you can just about see there, maybe. The quantized LED is just flashing. I'm going to turn it off just in case it's, doing anything dodgy. But yeah, and according to the service manual, because the service manual is really detailed, that indicates that the voltages have gone out of spec. So I'll unplug that there. But yeah, the voltages are out of spec. So it's kind of also initiating some sort of protection procedure and shutting itself down. But when you see something about voltages going out of spec and potential liquid damage on what should be quite a simple PCB, that says to me that there's presumably a failed component or a short circuit that's causing the voltages to be dragged down. So let's get this board out and see what we find. Cool, so now we know that the fault's still present, we can start getting down into it and get the parts out. So the faulty board is under this side here. It's a bit tricky to sort of visualise because it's been flipped over. But the faulty board is over here and the working board should be over here. So it's all under this main processor board. And this is what I was saying about the layout of these things. What you'll find is that all these boards are literally just going to be buttons, LEDs, very basic passive components. And then it's got these massive ribbon cables where each sort of conductor on that cable carries a signal for a different button. The only other boards here that really have logic on them beyond the main processor board are within the jog wheels because they've got the LCD display and stuff like that. So this is the main processor board here, so this is where all these cables come up and connect to. So what we'll do is we'll just go around, disconnect all these cables, and we can lift this out. So disconnect all these, and then to remove it, there's a few screws. There's silver ones here, here, and then black ones everywhere else. Take those out, that should lift out. So all we need to do is disconnect these cables. So there's two different types of connectors here, or three. You've got ones for these ribbon cables that you lift up, some here that you pull the front forward and pull the cable out, and then some more traditional connectors. So I'll show how to disconnect each of those, and then we'll get the board out. So these are the different kinds of connectors you'll find. For some of them with the higher density cables, you've got this type here where you lift the top up, and then the cable comes out, and then you can close it down again. These ones on the other hand, you pull forward, you should probably use 2 fingers to do it, but I'm holding a camera right now. So you pull it forward like that, and once that's pulled forward, the cable comes out. Okay, so I've now unscrewed this plate here, and I've removed all the other screws, so this can all now come out. But this is what I was saying about how good these things are to work on. Because literally every connector here has all the pins labelled on the PCB itself. So yeah, with all those screws removed, I've also removed them from over here. We can now remove the power supply board, which needs to come out first because it gets in the way. So that unhooks like that. And then this entire assembly should just lift out. Yep, with them all now removed, we should be able to hopefully, carefully, lift this entire assembly out. So that now is the whole main sort of processor board, main board, whatever you want to call it, for this controller. And this is the place where basically all the digital circuitry is. It's all on here. There's not really much below that. Everything else is just sort of analog inputs apart from really the sort of LCD controllers and stuff like that. So that's the board there. Now, it looks okay. Given the liquid damage was mostly up here, given where it would have come through those buttons, I can't really see any damage up here. There is a little bit down here, interestingly, coincidentally next to the crossfader. Ooh, the crossfader connector that seems to have been hand bodged back together. So that might explain why the crossover's not working, or crossfader's not working. It may not be, there may be other faults. I can see some sort of liquid residue around here as well. So that could potentially indicate something to do with the crossfader issue. I'm not sure if that's either been a previous repair that's either still finding the problems elsewhere or the repair is faulty. Or whether it was maybe, I don't know, they've taken it apart to try and fix the leak issue and then they've damaged that connector pulling it off, which is what's probably likely. That's definitely not going to be an official service centre repair. That's definitely a sort of homemade repair. So hopefully I can maybe even clean that up and maybe fix the crossfader if that turns out to be the issue. But equally the issue could be somewhere else on this board. But that's now freed us up to access the boards that have got the liquid damage, which is this one here. And yet we'll go in closer in a minute and take a look, but I can see a little bit of liquid damage on that, so that's definitely damaged. And this here is the working board we can use as a sort of reference. But what we'll do, before we go into that, we'll take a closer look at this board and see what chips this has, because this is actually a really interesting board. Cool, so now before we get digging any further, let's take a look at this board, because this is the main brains of the operation. I won't read out all the part numbers just because that'll take ages, but what I'll do is I'll put them up on the screen. So over here there's 2 microcontrollers, and these are from Renesas Technologies, and they're 32-bit RISC microcontrollers. They look very similar to what was in the DDJ-1000, and that was also a Renesas chip, so it might be similar, not quite sure. If I remember anything, I'll work out what that one was and put them both up. But these are identical chips, and on the service manual, they're labelled as USB-A and And I think that's probably because like each of these microcontrollers has one USB interface. And then other than that, they're different, they handle different things. So some controls and inputs and buttons connect to one of them, some connect to the other one, and then there's a bus that connects both of them together. Then down here there's another two microcontrollers. These are 16-bit Renesas chips. And again, I think they're just there to provide additional I/O and additional connections to different devices. So there's just another pair of microcontrollers. On the service manual, one of them is labelled mixer, one of them is labelled deck, and I think that basically defines what sort of roughly they handle. One of them handles the mixer controls, one handles more the deck controls. And these again link up to this. I think it's all SPI going between them really. So it's really just a lot of off-the-shelf microcontrollers that all just kind of talk to each other and handle all the I/O. Then down here you get the really interesting bit, because this is the DSP. And it's a Texas Instruments DSP, and this is obviously what handles the mixer. And this obviously wasn't in the DDJ-400 because it doesn't have a built-in hardware mixer, whereas this does. So that's the DSP there. And I looked it up and found a few other Pioneer service manuals. And it turns out this is the same DSP that's not only used in the XDJ-XZ, I think, which is their all-in-one DJ system, it's also used in the DJM-750 mixer. So actually, as when I said earlier that it looks like a sort of DJM-750 mixer in terms of the features, it actually has the same DSP in it. So in terms of hardware, it does essentially have a full Pioneer mixer in it. Connected to the DSP, there's this chip here, which is some SD RAM. It's 128 megabits or 16 megabytes. So yep, that's basically RAM for the DSP there. Over here you've got the DAC, the DAC, which is potentially where the fault is. But I have also noticed that there's been another attempted repair here on that capacitor, which looks again very dodgily done. Now, I don't know if this is actually going to solve the problem, or if this actually is the problem, because I suspect a single capacitor would only affect one channel, so like you might lose a single speaker if a capacitor was faulty. It wouldn't mean that there's no audio output at all, but it's something worth looking into, and it does show that someone's definitely been playing around in here, which is always a little bit concerning. All I can hope is that this sort of bodgy repair was done before the liquid spill. Potentially the previous owner bought it second hand, and the liquid spill is a very simple fix, and they've not actually attempted to fix it, and these attempted repairs were done by someone else. I suspect they would be, because if you're going to even bodge it, but you're going to try soldering or something, you'd at least try and clean this board off, which doesn't seem to have happened. They don't seem to have even taken it out at all. Next up here, you've got all the inputs. So over here, there's going to be a bunch of ADCs. They're going to convert the signals coming into the inputs to digital, send them over to the DSP, which will do all the processing, which will then convert them back to analog and send them out. Finally, over here, there's a bunch of voltage regulation and a couple of fuses, which I've checked, and annoyingly, they're actually okay. I was hoping maybe I saw the fuses and thought, oh, maybe one of them's blown and that's why it's not working, but no, the fuses seem fine. But this is quite common in a lot of Pioneer kit, that they have soldered in fuses that do tend to blow. So yeah, if you've got a Pioneer piece of kit and part of it doesn't work, definitely check all the little fuses that might be in there. And they do actually explain the part number to replace it with. So yeah, what we'll now do is we'll get these two boards out. So we've got the damage board here, which you can see there does have some sort of liquid damage on that plastic, and the working board, which is over here, so we can compare them. But very quickly before I do that, just before I take it apart any further, I'm going to try and really bodgily solder that back together. I'm not going to take it off, I'm literally going to dab a bit of solder on it, because when I was testing it, I put a multimeter on one of the vias on the board that went off the centre pin, which is the crossfader data pin, and put another multimeter probe on the top of the pin. And if I just touched it, it didn't get continuity, but if I pressed down, it did. So it seems a bit like maybe that centre pin which carries the crossfader data is just not connected properly. Now, obviously, if that fixes it, I'll properly take this off, redo it properly, maybe even put a new connector on it, I don't know. But I just want to see if that does actually fix the crossfader. Just out of interest, and then we'll dig a bit further and get these other boards out. Okay, so I've gone in and I've just resoldered the middle and the furthest connection. So the middle was definitely dodgy, that's crossfader data, and the ground wasn't connected either. So I've resoldered both of those, and hopefully they'll hold up. Now, I'm not going to trust this long term. I just want to see if this fixes the crossover, just give myself a bit of motivation for this project. If this fixes it, I'm definitely going to take this fully off and redo it properly, but for now, I'm going to very carefully try and put this board back in. I'll try and probably leave it upside down and hang it offside the table or something, just so I don't need to screw it in, and see if that's fixed the crossover, because hopefully it will. And I know I keep saying crossover, I mean crossfader, I just keep saying the wrong word, but yeah. Hopefully that fixes the crossfader. So yeah, just simple bit of soldering, and hopefully that's fixed it. Okay, so let's see if that's fixed it. So I've put the boards back very briefly, just like 2 screws per board. Put it in service mode, where basically what you do is you hold down the memory button and the left search button and turn it on while you're holding them. And it started in service mode. As you can see, it comes with this version display. So this is all in the service manual, it's very detailed. But if we press through this here using the effect button, it skips through various settings for testing different things. But if we go through these, we should find the crossfader calibration section. Now, officially when you're meant to do this, they sell a little jig that goes into this slot over the crossfader. You take the cap off and just a little metal bit sticks through, and it positions it at precise positions. I don't have that, but looking at the service manual, they basically want it positioned, I think, in the middle there, potentially. Yeah, it's kind of positioned in the middle. This won't be precise, I'm just literally testing it. I don't even know if I fixed it yet. You basically need to position it there, in the middle, and then sort of in the middle, halfway there, and then at the extreme ends. So with that there, what we do is we press this pad, goes green. Okay, that's good. So it's now read a value of 540. Last time that was only reading either like 128 or 1024, like a very high sort of full binary number, or like 0 or 3. So it's now actually reading a value that looks more like it should do. So next up, you need to position it, reading the service manual off camera because I forgot to read it before I did it. Let's see. We need to position it into the middle. So put that in the middle. Press the next pad, goes green. 526, so it's quite a similar number, but it is different, so that's good. Now you need to position it there. Press the third pad. 514, cool it is. Hopefully okay. So now we need to press hotkey, and this will save the calibration. If this pad lights up red, it means it's not happy with the value, so let's see what it does. Oh, okay. It didn't do that before. When you pressed hotkey, that would light up red, indicating there was a fault. But now it's gone on to the second set of calibration. So now, we need to move it to the next position, which again, read the service manual off camera because I forgot to do it properly. We now need to move it all the way to the left-hand side and press this pad. Yep, it's got a number. All the way to the right. Press the next pad. Yep. And now press pad effects 1. That looks like I've been able to calibrate the crossfader. So let's test it out. So now to test it out, all we need to do is we press this effect button to skip through the test modes again to volume fader. Press left there, which puts it onto this. Basically, there's different pages of different faders you can test. So if I want to test, say the high effect or something, you can basically you do that, and then it picks the controls that will be represented, and it represents the controls that are selected here on some of the LEDs. So you put it to 6, which is where the crossfader will be. Crossfader there. If we change that, that works. So you can just about see there. As I move the crossfader, those LEDs change. So I think I've been able to fix the crossfader. It wasn't the thing I was going for. I was aiming to fix that board up there, but I think I fixed that. Oh, just one more quick thing. I've turned it on normally now, and because the crossfader is now calibrated, the Q lights don't flash and they work fine, sort of as normal Q buttons now. So that's great. Because realistically, that was actually the annoying bit about the crossfader. I don't need the crossfader, but it would be quite nice to see these when they light up, because otherwise when they're flashing it's a bit tricky to use them. So what I'll do is I'll flip upside down and get these two boards out so we can look at those. Okay, so that's now taken apart again, and here's the board I think is causing the problem. And as you can see, there is some level of damage there, and I don't know if there's no component on the other side of that plastic, so I think that's presumably corrosion from the liquid rather than something that's actually blown up. But yep, that's the board there. So I've already disconnected it, and we'll take it out. So the way this works is you've got this board here, which has the rotary encoder for track selection, the quantized LED, and the slip mode LED, and button, obviously. That's on this board here. That comes across, connects into this board, and this board then connects to the main board. And I'm pretty sure all that happens is the signals from this are just carried through this board onto this connector, just to sort of, I don't know, combine cables, I suppose is the word to describe that. So if we take that there, we can hopefully lift this board out and see what it's like underneath. So that's there, there's all the buttons, and that's the board. And yeah, you can definitely see there is damage. So you can see around that LED there, there's sort of browny sort of corrosion on the board around the LED. There's definitely some level of corrosion. So liquid has definitely got onto this. So what I'm hoping is it's something fairly simple I can fix, because as you can see, as I suspected, this board is actually really simple. It's buttons, LEDs, little capacitors, and on the back there's a few little surface mount transistors, and I think they seem to just be using those to switch the LEDs, because there's one per LED, so I think they're basically using that to switch the LED. So yeah, there's nothing too complicated on this, and realistically, even if I have to start replacing components off this board, it's all off-the-shelf stuff. It's not like I need to try and source a microcontroller that's going to have custom firmware on it or some sort of Pioneer chip. It's literally just standard off-the-shelf parts. So yeah, that's the damaged board there. You can see, if you hold up the light, it's only a double-sided board, I think, so it doesn't look like it'll be too hard to work on, so that's pretty good. So that's that board there. We'll do the exact same to get this board out here, which is the working one, and then we'll start comparing them. Okay, so we've now got the two boards out. We've got this board here, which is the faulty one, this one here's the working one, and what you can see on it is there's loads of little test pads. So there's test pads for all different voltages. Turn it the right way up, make it easier to see. You can see over there, there's all the different voltages on little test pads. There's definitely signs of corrosion on this board. What I'm going to do is I'm going to go through, measure all the resistances between various voltage rails, ground, all that sort of stuff, on this board and see if there's any differences. Because hopefully, given the voltages are going out of whack and that's what's causing the issue, it might be a simple short circuit on this. Okay, so I did what I said I did. I've tested between the various voltage rails and ground, and I think I found a problem on the faulty board. So if we look at the good board here first, if we test between ground and the 3.3 volt rail, it's fine, there's no continuity. And between ground and the 5 volt rail, labeled 5 volt LED, there's very, very high resistance, but nothing really to write home about. That's probably through a transistor or something. I mean, that's 39 meg ohms, if you can't make it out on camera. On the other hand, if we look at the faulty board, if we test between ground and the 3.3 volts, that's absolutely fine. But if we go between ground and the 5 volt LED, it's basically a dead short. I mean, that's what, 26 ohms? And I mean, yeah, there's basically no continuity, or basically a short circuit there. So I suspect that might be the issue. Somewhere on this board, there's a short circuit between the 5 volt LED and ground, and that's what's causing this to obviously cause the voltage to drop and the system to go into that voltage error mode. So what I'm first of all going to do is I'm just going to go and try and fix this. Now, I'm not going to do all my attempts on camera because that's just going to be a total pain. But what I'll do is I'll go away, try a bunch of stuff to try and fix this board, and we'll come back. My first protocol is literally just going to give it a good clean, just alcohol contact cleaner, just whatever I can really think of to try and clean it off. See if that helps. If not, I'll then need to probe around, see if I can find any shorted components, maybe take little components off. There's all those transistors that all they really seem to do is drive the LEDs, so maybe take those off, or take some of those off, see if that helps. There's some LEDs on this side that have got pretty visible corrosion around them, maybe take those off. Really just see what I can do. Because with this, that 5 volt rail is just for the LEDs, so potentially even if I just got rid of that rail, disconnected it, it would still work for the buttons, just not the LEDs, but obviously I want the thing to fully work. So yeah, I'll go away, try and clean this, and see if I can get rid of that short. Okay, so I'm back. So I've tried cleaning the board with contact cleaner. It looks a bit better. I mean, the contact cleaner left a bit residue, but it looks a bit better, but it still has that short. However, the good news is that I've kind of isolated the area that can possibly contain that short. But the bad news is that the reason I can isolate that area is because it seems as though a lot of the vias through the board are corroded. So even though the 5 volts comes in here, it doesn't seem to have continuity from here to where it should be on the rest of the board. So like it should be up here where these transistors are and around about here, and there just isn't anywhere there is continuity on the working board. But it seems to be the vias around this area here. Basically, the 5 volts comes in, it snakes up diagonally up to this connector here, and there's 4 different vias through the board that carry that to the other side where it's then routed to different LEDs. And there's what, 5 different LEDs. I mean, there's pairs, but there's 5 different LED zones that are switched separately. So it seems as though the only place the short can really be, unless I've got something wrong here, is potentially with these 2 capacitors or something. I'm not sure, because the 5 volt signal or wire or whatever you call it, trace, doesn't seem to actually really make it through to the other side of the board. So what I think I'll do, I think I'll just bite the bullet, take off those 2 capacitors, because they only go between 5 volts and ground, so that if they're there at all, if they're needed at all, it's just interference suppression. See if that clears the short, and if that works, then we'll go from there. It is worrying when the vias are corroded though, because that indicates that there's probably a lot of more issues on this board. However, it's the sort of thing that with enough bodge wire soldered onto it, you could probably fix it. So yeah, I'll pop those two capacitors off just to see if that clears the fault, and then we'll, well, go from there. I tell you what, I think I just had a very lucky guess there. So I took the capacitor off, or one of them, tiny little surface mount thing, and the short seems to have cleared. So that capacitor, if I measure that, it's got a dead short across it, or at least around about 23 ohms, which was the value of measuring. And now, if we measure between the 5 volt LED pin and ground, you know, that's now about 35 meg ohm. That's basically what we were seeing on the other board, on the good board. So, yeah, now it's basically clear. So that looks like I've actually managed to clear the short. So that's a really good sign. Now, of course, as I've mentioned, there's obviously fairly major other damage on this board. But what I'll now do is I'll pop this back into the machine and just see what it does, because if I've cleared that short and it's no longer bringing the voltage down, then let's see if it'll fire up with this connected and what it'll do. Okay, so now put it back together, again very badly with just like a couple of screws in each board, and I've not turned it on yet, so this is genuinely the first time I've turned it on, but the board here is now connected. So previously that would cause it to fail and flash the quantized LED, so let's turn the mains on, turn it on and see what happens. It booted up. Okay, that's very positive. So it has now started up with this board connected, and while it was connected, I saw the quantized LED light up, not flash, just light up, which indicates, which it does when it's starting up. So it seems as though the quantized LED was getting power. Slip mode didn't seem to, and the other things didn't seem to, but it did seem to turn on, so that's interesting. So I'm now going through and I'll try and get it set up so I can press these buttons, see if any of the buttons work. The LEDs didn't light up, but I suspected that would be the case because of that issue with all the vias being corroded. But the key thing is that it's now been able to boot up with this board connected, which it wasn't able to do before. Okay, so there appears to be some life in it. Not much, but a little bit. So it's now in this button test mode. So when I press a button, you'll see it'll signal on the screen there. And when you do it, usually the light goes out so you can kind of like see which ones you've tested. Obviously the lights don't work up here anyway, but you can see it's kind of working. Now obviously over here on the working side, if we press things like loop in, loop out, all the buttons work. Up here, not many of the buttons work, so none of the ones on the actual board I've had out before work, but quantize works and slip works. And I think also back works. Yeah, back works, but view doesn't, and the rotary encoder doesn't seem to work either. But that is a very, very positive sign, because yes, only the quantized LED works as well, but it seems to be that some of the buttons work. They're all on this board here so far, but that shows that signals from here are now passing through the damaged board. So really all I need to do now is just take it out again, and I'm just going to sit with a multimeter and just probe all over the place and see if I can figure out some way to get continuity back through that between these buttons and the connector that goes to the main board. It's probably not going to be pretty, but it's pretty positive that it now actually starts up with that board in place, and at least some sorts of signals are able to get through it. Okay, and I think I've actually finally fixed this board. That was a complete pain, but I think I've sorted it. So, as for the faults, when we last tested it, I mentioned that a couple of the buttons on the rotary encoder board and slip mode button type stuff board, a couple of the buttons on this worked and a couple didn't. And then none of the buttons on this worked, and I thought, oh, it's going to be the vias and they're all going to be corroded, it's going to take ages. But actually it wasn't. All of the issues with the buttons not working and one of the LEDs on this board not working was, and the rotary encoder, was just down to the soldering on this connector here. So all I did was, and I say all I did, it was a complete pain, was go down with the soldering iron and just reflow it. Now, I really should have used a hot air station, and I almost bought one because I messed this up so badly. I managed to solder a bunch of the pins together and had to try and clean them all up. It was a real pain. So I was actually about to order a hot air station, but finally managed to fix it with soldering iron before I did. So yeah, I would definitely recommend if you're doing this to get a hot air station. But I was just about able to do it using this sort of chisel tip on a soldering iron, but it was definitely not ideal, so I wouldn't recommend using a soldering iron. But I was finally able to clear that up, get them all soldered and not have any pins shorting together, because I was literally having shorts develop again, and that where like I shorted 3 volts to ground, it was a complete pain, but eventually cleared it up. There's a very slight bit of thermal sort of burning on that, but it's fine. So that works absolutely perfectly now. And as soon as I soldered that, all the buttons started working on both this board and the other board that's connected through it. The rotary encoder started working, and on this board, both LEDs started working. So the final thing I had to do was sort the LEDs on this board. So with this board here, it turned out the problem with the LEDs was entirely because the 5 volts wasn't making it up to each group of LEDs. The transistors were fine, the resistors were fine, the LEDs were fine. It was just the vias around this area here where the 5 volts comes in were damaged. So all I needed to do to actually fix the LEDs was put these 2 bodge wires in. So as you can see, this wire, or this one here, comes from the 5 volt test point I was testing earlier. It comes up here, and I've just soldered it onto the side of those resistors there. And those resistors are all common together on this side, and it's 1 resistor per LED, because this section here has 3 LEDs on the one button, so there's 3 LEDs, 3 resistors, 1 for each LED. Then, as you can see, we've got this transistor here, which is switching those 3 LEDs. Then for this LED here, we've got 1 resistor and 1 transistor, and then over here, for this LED, we'll once again have, yep, there you go, 1 transistor, and the resistor is just underneath that wire there. So it turned out that all I actually needed to do is put this 1 wire up to here, onto that point there, and the traces in this area were still good enough condition that 5 volts from here is successfully carried to all the LEDs along the top here, which meant that as soon as I put that first wire in, these 3 yellow sections of yellow LEDs started working, leaving only the red ones on the loop button not working. So for that, all I needed to do was put another wire in. So that wire comes from the 5 volt test point again, over to here, and once again connects onto the resistor, or the 2 resistors there. The output, the other side of the resistors goes to the LEDs, then the other side of those LEDs goes to the transistor down here. And then that transistor essentially connects directly onto this. There's basically a tiny little trace connecting into this ribbon cable. So yeah, that's all it actually took was those 2 wires, and that fixed all the LEDs. And I just hot glued them in place just to stop them moving around, because I don't want to just rely on the solder joints. So, yep, it's not the neatest job in the world, it works perfectly fine. And this board now works. So all we now need to do is get this board and this board connected up to the controller, and look at them working. So there we go, that's both boards now connected up to the controller, and as you can see, all the LEDs are lit up, which it wasn't doing before. And now if I press each of these buttons, you'll see the respective LEDs will go out, which indicates that all the buttons are working. Oh, get them there. And that one there, and that one there. These buttons and the rotary encoder and this one here for the deck select also do work. They're just, these ones, because they've not got their own LEDs, light up LEDs on the other side of the controller, and because it's sort of standing vertically, I can't really show that on camera, but I'll demonstrate it properly once it's all put back together. But that proves that these boards are all now working. So at this point we could actually just reassemble the whole controller, and that would actually work. But the final thing I want to do is clear out the dirt in that jog wheel, because I've already kind of got it partially disassembled, and I'll need to disassemble it further to get into that jog wheel. So I'll do that first before I put it all back together. So we'll take the jog wheel apart, take a quick look at how it works, clean it out, and then finally we'll be able to reassemble this thing. And also just a quick word of advice. When you go to check the remainder of the buttons on this board off camera, just check that these ones that don't have LEDs are working, and then panic because they're not working, you think the board's broken again. Check you're actually pressing the buttons on the board that's connected and not the one that's sitting off to the side that's not actually plugged in, because I just did that and panicked. But yep, test all the other buttons and they're all working fine. So yep, we're good to go. Okay, so now we take the jog wheel out. So I've already taken the main PCB out and everything, we've got it stripped down to where we were before. So to get the jog wheel out, well, first we'll need to take out this board here. This serves all the pads, the pitch fader, that sort of stuff. So I'll need to take the pitch fader cap off, and then this board should just come out if I unscrew it all, and then we can hopefully get the jog wheel. So yep, we'll do that and we'll come back. So that's that board now removed, and as you can see, it's basically the same sort of idea, because it is just essentially like a keyboard style contact thing where like there's this conductive pad that presses down on this. So not quite sure what those signals are for. Thankfully this board isn't faulty, so I don't need to try and dig into that. But as you can see here, there's also RGB LEDs on each pad. So this board is a little more complicated, but again, ultimately you can still see it's buttons, LEDs, and faders, and that's literally it. So in terms of the complexity for like repairing another board like this, even this board wouldn't be too hard to repair if I figured out what those signals meant. And the service manual does actually detail what the signals are, so I could just read that. So with that board out of the way, you can now see here we have the jog wheel. So yep, need to be very careful because I'm just realising I'm throwing these cables out the way, and that needle needs to go into a very specific place on the main processor board, but that's those out the way. So now I've got the jog wheel. So to take this out, I think I'll just need to take this board out, this piece out here, so it gets out of the way, and then there's a bunch of screws around the outside, and then the whole jog wheel assembly should come out of the machine. So that's jog wheel now unscrewed, so the whole thing will just lift out the machine. So that comes out there, and yet you don't want to undo those screws there because that's part of the jog adjust assembly. And if you take that apart, I don't know what would fall out, but you probably wouldn't want to do that. So, yep, that's jog wheel out there. So we'll get the rest of the machine out of the way, dig into this, and try and clean that mess off underneath. Okay, so here we have the jog wheel assembly removed. I'm not going to take this plastic off the back because we don't really need to, and there's not much to see under here. There's just a big microcontroller that's the same Renaissance model as on the other boards, so they just use the same microcontroller throughout. That'll drive the LED or the LCD and also do all the jog wheel type stuff. Big ribbon cable here. See all the sort of signals on it there. Just basic serial communication between this and the main board, because also that'll have to talk to the microcontroller because it has to do the LCD and stuff. And there's the photocell type assembly that's doing the jog wheel rotation, but we'll look at that better on the top. So if we flip it over, you can see we have the top, and there's the sort of mess we need to clean out. Now you can see it's on the inside because if I rotate that, it doesn't spin. So what we'll need to do is we'll need to take this apart. So it seems pretty easy to do. There's just little clips around the side. So if I undo those clips carefully, shouldn't do this while holding the camera, but I am. That'll remove this surround, that comes off. And now we can see we've got this sort of the top part of the jog wheel, because obviously it's the two parts because it's pressure sensitive. And then if this part comes off, we can see we have the assembly. So there's the part we need to clean. Annoyingly, it looks like that dirt is actually even further down, so I might need to actually take this like plastic panel off. I think it's actually on the LCD itself. That's not ideal. I'll do that off camera because I think trying to do that on camera would be a total pain. But that's dirt we're trying to try and clean out. But what's more interesting is seeing how this works. So for the pressure sensitiveness, you've got this sort of white piece here, which has little wheels on it that the wheel runs around on, and that's spring loaded. So if you press down on that, you see it springs. So when the top of the jog wheel is pressed down, it presses that white piece down, and it'll detect that on the contacts underneath. Then these outer wheels will handle the surround, so the surround can spin independently, and the middle piece can get pushed. Obviously LCD here, these are just LEDs that shine through the LCD. I presume, unless they're actually like using part of the LCD panel to light those up, I suppose they could, because if it's like a square LCD under here, they might, don't know. Jog adjust, what you've got is you've got the jog adjust knob here, and as you can see, that adjusts a little piece inside there, and that just adjusts the tension on this wheel here. Because if you look on the underside of the middle part, you'll see there's teeth, so they will grip onto that, and that will allow it to adjust the tension. And then for detecting the motion, it's pretty cool. So down here, you've got this little wheel here, which again will go into the cogs, or the gears, or the whatever you call it, on the back of the piece here. So when the top of the wheel's turned, it'll spin this. And as you can see under there, just about make it out, there's a little clear film. Turn the light on the camera, see if that lights up a little bit. But there's this little clear piece here. And it won't really come across on camera because it's so small. But if you can just about see, there's like a sort of printing on it, like a sort of ring round it. Now that looks like just a black ring, but it's not. It's loads and loads, a huge number of tiny little thin lines that are going sort of sticking out from the side of that are running towards the edge of the wheel. So what happens when this turns, those lines will go under this photocell and it'll see the change from light to dark. And that must be super high resolution. Because on the DDJ-1000, if you might want to look back at the teardown of that, we looked at the jog wheels on that, and it's got similar sort of cogs on the bottom of the wheel, but those are read directly by the photocell. Whereas on this, these turn this cog, which turns that little wheel underneath. And if you think of the sort of gearing ratio on that, how quickly this is going to turn, and how many of those little lines can move past that photocell for even the slightest motion on this, that is going to be extremely high resolution. And that's the things you get with these higher end controllers. Not only do you get the fancier mixers, you also get things like the higher end and higher resolution jog wheels. So yeah, that's really cool to see that. That's definitely much better than on the lower end controllers. So yeah, that's that there. So what I'll now do is I'll go away off camera and try and see if I can get down to this LCD to clean it out, because this looks like it might be a nightmare. If not, I might just need to live with it, but hopefully I can clean that up. Definitely getting deep into this thing now. So I ended up taking the plastic off the back of this, removing the main PCB with just a few screws, and then taking the LCD module out, hoping that the plastic bit on the front would be separate, but it actually all came out as one part. But yeah, it's all just fairly easy to take this board out, and as you can see, there's the main board that handles all that. Only tricky thing to bear in mind is there is actually a connector on the bottom that goes off to this cable here that goes to the pressure sensitive detection. So I had to, I almost damaged that, but it was fine. So that's now off there. But we've now got this piece. So it turns out this is all one part, but this plastic piece is just stuck on, so I probably could have got away without actually taking this all apart and just doing it from the top. But I've gone around, carefully unstuck, I mean not carefully, but pulled this plastic piece off, and as you can see that's now come off there, and there's the LCD, and there's the back of that. So that's a bit I need to clean up, so I'll go and do that. Don't have a clue what someone spilled under here. I don't know how it got, I don't know how it got into it, but anyway, it happened, so we'll clean it up. And quite interesting, as I suspected, that even though here you've got these basically LEDs for the deck selection and beat sync, those are actually just driven by the LCD. So that's kind of cool. Don't know why they didn't just, you know, leave that on the LCD. I don't know why those have to then be, you know, lit up through that, why they can't just use the LCD to display that entire graphic and have a square LCD. Bit weird. But anyway, so yep, get that cleaned up. Get this piece cleaned up as well because it's a bit grubby as well. And then get this thing put back together. There we go, all cleaned and reassembled. That looks much, much better. So that's now nice and clean there. So I can now put this back together. The only other thing I've done is I took these three screws on this white piece out, took the white piece out, and then there's 3 springs, 1 under each screw, and I just stretched them out a little bit. I think because I've been working on this face down without really putting it up on blocks, and it's been sitting on the jog wheels, which is a bit stupid to do, it kind of pressed the jog wheels in because I'd left it overnight. So it wasn't, when I put this top piece on, it wasn't really travelling much. So I was worried that I'd go to all the effort putting it all back together and find that it was kind of stuck down. I need to take it apart and adjust the springs again. So I thought I'll just do it while it's apart. And I'll see what the other jog wheel's like. It seems to not be moving as much as it probably should, so I'll maybe need to do that one as well. But I'll do that off camera. But yeah, if you ever find with one of these that the jog wheel doesn't press down properly, which is particularly common because a number of times you see people in DJ booths putting a laptop on top of a CDJ and it's just like, oh, because it'll damage the springs in the jog wheel, and it's quite, it makes me cringe when I see it, because you do see it. If that ever does happen, all you really need to do is take this piece out and just stretch the springs out a little bit. I suppose you could replace the springs as well, but it's not like a terminal issue. You will just need to stretch the springs out or replace them. But yeah, done that as well. So now this piece should go on top here, and then this round will go on. You need to line this up. There's like little pegs, you need to get that the right way around, and then we can finally put this thing back together. And obviously I've put all the boards back in underneath and stuff as well. So yeah, hopefully by next time you see this, the machine will be reassembled. So I'm currently in the middle of putting this back together, and I've attempted a repair. So this could be very reckless because I could have broken it totally, but I think I've maybe found a potential issue with why the audio output isn't working. So I've tried to fix it. So if you remember when I took this apart earlier, I saw the capacitor up near the DAC, which is this chip here, that was really badly soldered. It had clearly been replaced previously. So I sort of tested that, and it had a dead short across it. Seems a bit of a weird trend compared to the other one. So I've just taken that capacitor off, so that's it there, and yeah, it's totally shorted. So I took it off, but unfortunately the traces have lifted. Now, yeah, you can see it here. Now, I'm not going to take responsibility for that because I'm pretty sure they were already like that. The capacitor was always already at a weird angle. I mean, it kind of rocked, so I think the trace had already been lifted when it had been replaced previously. So yeah, that trace is lifted. And the problem is that this via here carries 5 volts to this area, and that 5 volts should connect under that capacitor, with the capacitor connecting across the ground, past this capacitor here, and into the DAC. And looking at the DAC's datasheet, that's the analog voltage supply. It seems to have 2 different voltage supplies to the DAC. There's a digital one and an analog one, and they're obviously meant to be supplied separately, presumably for some reason. So the problem is the DAC with that trace broken, wouldn't get its analog voltage supply. But equally, with that cap shorting its ground like it was before, the DAC also wouldn't have been getting its analog voltage supply. So that would kind of explain why I'm not getting any audio output. If this capacitor shorting it to ground was stopping the DAC getting an analog voltage supply, well, yeah, it would make sense. So what I've done is I've just soldered another bodge wire in. So I've put that bodge wire from this side of this capacitor here that's on that same trace, all the way over to this 5 volt reference point here, or this 5 volt point here. And this 5 volt point has perfect continuity to the pad that's broken off here. So this would have been actually the correct voltage rail that would actually be designed to power the DAC. And if you look at the datasheet, it actually names all them, so it says that the DAC is powered by 5VA, which is the one down there. So yeah, all I've done is I've soldered this wire that goes all the way across, hot glued in a few points, and essentially connected it up where that trace should have been. So it's exactly the same as it should be, just minus this capacitor here. So hopefully this is just some sort of interference suppression thing. I'll see how it works without it. You know, there might be a weird noise on the output, or it might make the chip unstable, I'm not sure. If that was the case though, ultimately I've got the capacitor, so I know the value I would need. I could just solder a new capacitor in, but I don't think I would go for another surface mount one like this. I think I would just fit a sort of leaded capacitor and just solder the legs on. That'd be much easier. But yep, so that's now there as well. So either this will not make any difference in the audio output, it still won't work, the audio output will work, or I'll have totally broken the whole thing. So yeah, time to continue putting this together and see which one of those answers it is. So that's all now assembled. I also ended up taking the other jog wheel apart because it was having the same issue where it wasn't very springy because I've been sitting it face down, so I've fixed that one as well by stretching the springs out, and I've now got it propped up on 4 cans to try and keep it off the table. So I think if you're working on this, yeah, you'd want to keep it on like a couple of cans or just anything really, just to keep the jog wheels off the surface. And I suppose if you're doing this a lot, even having some sort of like test jig or like a, wooden frame to like leave it on or something, or at least at the very least, if you have to take one of these apart and you don't have something like that, just minimise the amount of time it's on its face. Take it apart, get the components out you need, and then flip it back over again. Don't do what I did and like leave it face down overnight because that caused that issue. But they're perfectly fine now, so that's good. So it's all now assembled. So now let's get the bottom back on and try it out. Okay, so it's all now reassembled. So in theory, this should all work. So I've got to connect up to laptop running Rekordbox, just load some YouTube audio library music in there, and let's turn it on and see what happens. So I've dimmed the lights. It's still not super easy to see on camera, but we'll see what happens. So we turn that on now. There we go. You'll now notice that the lights that were previously not working are now lit up because it's actually now working. Well, that board's now fixed, so it's able to start it with that board connected. Laptop's now saying the controller's been detected, don't want to use it. Yep, so do that. Takes a little second for it to recognise it. There we go. So let's see, this should now work. So first of all, we'll try the deck that had no issues before that hadn't taken apart. Seems fine. Well, at least the rotary encoder seems to work, so we can load a track like that. Play that. And yep, that's working. I'm not going to edit the audio in because it's just pointless YouTube audio library music that's being very badly played about with because I'm not really doing anything properly here, I'm just testing it. So I just get my microphone audio, but it'll give the idea, but that's working. And obviously, jog scratch works. Pitch bend with the jog works, and that's not affecting not scratching, so the springs are definitely working correctly. If the springs are dodgy in this, you'll find that it'll always scratch. You won't be able to just do a pitch bend, it'll always do that. So that seems fine. Obviously, temp fader works. That all would. So that was a deck that obviously all I changed was play about with the jog wheel springs. I didn't do much on this deck. So this is the one that we actually did the work on. So let's see if it works. So first of all, if we try and pick a track with a rotary encoder, you can see it's now working. So that previously wouldn't work. So I can now pick a track, pushing that in works, that's good. Start track off. Obviously that would work. If we pitch bend works fine. Scratching works, seems reliable. The screen looks really good, it's much clearer. Bring it a little bit closer so you can see that. So yeah, the screen looks really, really good on that. That looks absolutely excellent. Bring the volume down a little bit, but that was absolutely excellent. The screen there, that works absolutely perfectly. And now the moment of truth is looping. Does the looping work? Because this was the thing that obviously was critically missing before. So let's try and bring it back section. There you go, there's a loop. The loop has worked. I've been able to create a manual loop. That's excellent. And in theory I can, oh, that's in adjust. I can half it. Yep. So all the looping functions for the manual looping works, which is the main thing I really need to fix with this. So that's great. Does the slip mode work? Yep. Slip mode works. Quantize turns on and off. So basically all these controls up here that weren't working before are working. In fact, can we even use a deck select? Because this is the thing with this controller is it's 4 deck. So with each of these 2 decks, you can switch it between 2 different virtual decks almost. So while that one's playing, I can switch on to deck 4, load a different track, there, hit play, bring the fader up, and there you go. That's 2 decks, or 2 tracks playing off the same deck. So that's working. So even the deck select button works. Finally, I think the final one we need to check is slip reverse. Yep. That works absolutely fine. Obviously if you shift that, it'll do a normal reverse. So, yep, that deck works perfectly. So that is perfectly fixed, which is great. So now the final thing to look at is the crossfader, because this is the thing that was obviously very badly soldered. Now, I said previously I was going to go into the crossfader and try and adjust the, or try and take that connector off and resolder it completely. I've decided against that because I looked at it in more detail, and what seems to have happened is I suspect the connector's been broken off and then they've ripped off a trace. So when they've tried to resolder it, it's not, they've kind of soldered one of the pads, one of the sort of legs off the connector onto like a capacitor just because there's no trace there. So I'm not going to risk taking that off in case it causes more board damage. So all I've done is I've just covered it in a lot of hot glue just to keep it very secure, and I think it'll be fine. Well, if it works. So let's test the crossfader. So got a track on each deck here. Yep, the crossfader works. So yeah, the crossfader works. So now that we've seen all the controls working, what about the audio output? Has my dodgy repair fixed it? So what we've now got is we've got the controller is now hooked up to my speakers, so I've got this big long RCA cable going over to my speakers. I'm just using RCA cables for now. There is also the XLR output for the master and the TRS output for the booth. I've not connected those up just because I've not got the appropriate cables in the right length to get all the way over to my desk. So I'm just testing the RCA outputs for now. So that's the RCA output of the master. So that's going off the speakers. And I've also connected some headphones up, and I've connected these into the headphone output on the front. And previously, neither of these outputted any audio. So let's load up a track and see what happens now. So load that track in there. Channel fader's still down, so we're going to start track playing. And we're going to press the Q button, which will send the sound to the headphones. And that's working, I can hear sound. So at the very least, the headphone output is now working. That didn't work before. So that's really good. So we turn the headphones off, and let's bring in the channel fader and see if we can hear this on the master. That works. So yeah, I have successfully fixed the audio output on this, which is amazing given the absolute bodge that I did by taking a capacitor off and bodging a wire across it, but now the audio output works. Previously this thing was totally silent. So yeah, that is absolutely excellent. Of course all the effects will work. Oh, turn it on there. You can do a different effect on a different channel. Everything is fully functional. So yeah, this thing is, as far as I can tell, totally repaired. Yep, that is all absolutely perfectly functional, which is absolutely amazing. I'm kind of lost for words, like the fact that I've actually fixed all the faults this had is amazing. So yeah, let's stop the music and wrap this up. But yeah, everything is now fully functional. So there you go. I've successfully repaired this DDJ-1000. Despite all the faults it had, this dodgy board up here that was completely faulty and was shorting the machine out when it was turned on, so it had to be disconnected, the crossfader that wasn't working, and the fact that there was literally no audio output from it, everything now works. So realistically, all that needs done to this now to sort of restore it to sort of good condition is it just needs a really good clean. So I'll do this all off camera after the video. I'll just take all the knobs off, give it a properly good clean, replace this faulty fader cap just because that's a little bit loose, but even then that's not a problem. It's perfectly usable, it doesn't fall off, it's just a bit wobbly. It could maybe do a little bit of additional maintenance, like these faders. They're all okay, but they're a bit different from each other. You can feel slight inconsistencies in the sort of forces they require. Like this one's a little bit stiffer than this one. So they could maybe do with being replaced in the future, but they're perfectly fine for now, and those are easy to replace. And then finally the jog wheels. They're basically fine. They both, oh, that's going to make noise. They're both fine. If you're pressing them down, they're perfectly smooth. The only thing I found is that when you try and spin them on the side, there's a little bit noise there. There's a slight sort of squeaky sound. I suspect it's because I've been adjusted those springs, it's now got a bit of tension up and it's kind of grinding on the plastic. It really just needs some sort of grease put in it just to sort of loosen that up. I just don't have any to hand, so at some point in the future I'll probably take it apart, maybe give it more of a clean, maybe replace some of these faders and grease up these jog wheels, but other than that, this thing works fantastically. Everything works. So yeah, hopefully people find this video either useful if you're trying to repair your own DDJ-1000, or at least found it sort of interesting or entertaining seeing how the thing works internally, how the faults inside manifested, and how I repaired them. So yeah, Thank you very much for watching.